So in order to name compounds, ionic compounds or covalent compounds, we need to know a little bit about this periodic table. Now the first thing you need to know about the periodic table is if you look right here, you notice there's this extra bold line in the shape of a staircase that separates the right third of the elements with the left 2/3 of all of the elements on the table. Now the right one, all of these right here, these are all going to be non-metals. So these are all non-metallic elements. And so conversely, everything over here on the left side, the left 2/3 of the periodic table, these are all going to be metallic elements, metals. Now the exception to this is hydrogen, this one right here, where this hydrogen you can actually think of belonging over here in the nonmetals family. So hydrogen is the one exception, but except for that, everything on the right side of the red line of the staircase separation is going to be nonmetals. Everything on the left are going to be metallic elements. Now, why do we need to know that? We need to know that because the two major types of compounds that are formed between all these elements, one type of compound is called an ionic bond, and an ionic bond is going to be made up of one metal and one nonmetal. Now also there's going to be a covalent type of bond, and that is going to be made up of all nonmetals. So a nonmetal plus another nonmetal. So with an ionic bond, you're going to have something from over here, anything on the left 2/3 side of the periodic table. You're going to have one element from there, and then you're going to have one element from the nonmetals, the right third of the periodic table. That's going to be an ionic bond, and that's going to make up an ionic compound. A covalent bond is just going to all be made up of nonmetals. So a covalent bond or a covalent compound are going to be compounds made up of nonmetals. So now if you're writing an ionic compound, you're going to have a metal and you're going to have a nonmetal element in there. So what you want to do is you always want to write the metal first, and then you write the nonmetal. So say for instance, if you have, look down at the periodic table, if you want to write calcium and chlorine together, you would have up here calcium plus chlorine. And what you want to do is just make sure the metal is first, listed first, calcium, and you don't change that, you just say the word calcium, but instead of chlorine, you change the end of chlorine to chloride because it's in a compound. So all you do is you change the last part of the word into "ide." So what you end up getting is calcium chloride. And you can do this with anything that you put, when you put a metal with a non-metal for an ionic compound. Let's say copper bromide. Here's copper is a metal down here in the transition metals, and then bromine is right there. So you're going to have copper and bromine. So what you're going to do is you're going to keep the copper at the beginning, because you list the metal at the beginning, and then you list the non-metal. And instead of bromine, you change that ending to "ide." So that ends up as copper bromide. Now back to the periodic table. We want to start to memorize some of the patterns that are present here in the periodic table, because really the periodic table is like the cheat sheet to a puzzle you're trying to figure out. The periodic table will give you a lot more information than you would think at first glance. So if you look at the non-metal side, and the very first row, these are the noble gases, and the noble gases were named that because it was kind of a joke among scientists that they were noble, because the thing is about this row is that they are valently neutral, so they do not bond with anything else. And so the joke was that they're too noble to hang out with the rest of us, to hang out with the regular people. So that's why they're named noble gases. It was just a joke among scientists at first, making fun of like rich hoity-toity people. So they're noble gases because they don't bond with anybody else. So these have a ionic charge of 0. They're completely neutral. They don't bond. They don't make bonds with anybody else. So you don't really have to worry about them when you're talking about ionic bonds or ionic compounds. Now the rest of these nonmetals, you want to understand after the noble gases have a 0 charge. This next one over, you want to count from right to left. Everything in this column right here, the 7 column, 7A right here, this 7, this is the noble gases are column 8, 8A. So if you subtract 8A from 7A, you get 1. So these nonmetals in this column have a -1 charge to them. So fluorine, chlorine, bromine, iodine, they all have a -1 charge. Now this next column over, column 6A, 8 from the noble gases, the column 8 from the noble gases, minus 6 is this column, is 2. So these guys are going to have a -2 charge, because if you're noticing a pattern, the nonmetals are going to have a negative charge to them. And a negative charge means that these are going to be anions. And notice that word ion in the word anion. They're an ion that an means against, or in this case negative. So they're negative ions. They're negatively charged ions. Now back to this column with oxygen in it. This is column 6A, and 6 minus 8 from the noble gases is a -2. So these are going to have a -2 charge. Everything in this column is going to have a -2 charge. Now down to 5A, column 5A, 5 minus 8 from the noble gases is a -3. So everything in this column is going to have a -3 charge. This is a 4A, column 4. So 4 minus 8 is a -4. Now we stop doing that right here, because now we go on to the metals side of things, and the metals are going to be, for the most part, positive. And a positively charged element is called a cation. So notice the word ion in here. So an ion means it has a charge on it. And the word cat in this instance means it's a positive charge. So a cation is going to be mostly the metals here. So if you go down to column 1A, I know hydrogen is an exception. Hydrogen belongs over with the nonmetals in this, but we still have the rest of this column 1A, lithium, sodium, potassium. Here's lithium, sodium, potassium, rubidium, cesium, and francium. These are all column 1A. And column 1A is going to have a 1 positive charge to it when they're ions. Now column 2A, when they're in ion form, they're going to have a 2 positive charge. And then if you follow me all the way over here to the other A, because we're just dealing with A groups right now, this 3A right here, this boron, this is going to have a 3 positive charge to it. Now I know I said that boron is a non-metal, and so you would think that it would be a negative charge, but this is just kind of an exception. We're looking at the A groups here, and group 3A has a 3 positive charge to it. So that's just an exception. Now, when you want to actually write the formula for ionic compounds, what you have to remember is that ionic compounds are going to have a neutral charge. So these charges over here, the positive charges of the cations in column 1A is 1 plus, in column 2A is 2 plus, and in column 3A over here is 3 plus, and then the negative anions, -3, -2, and -1 in the 5, 6, and 7A columns, you're going to have to get enough cations and enough anions together so that their charges will equal 0. So say, for instance, we want to do calcium and chlorine. So down here on the periodic table, here's calcium right here, and then chlorine is over in the nonmetals section, in the anions section. So we're going to first know how to say this. We got calcium and chlorine. But remember, when an ionic compound, we always write the metal first, which is calcium, but then we take the chlorine, the nonmetal, and we change that last syllable to "ide." So that gives us calcium chloride. So how do we write the formula for calcium chloride? Well, first we have the calcium down here in the periodic table is in column 2A, so that means calcium is going to have a positive 2 charge to it. And then we look at the chlorine, or the chloride in calcium chloride, and chlorine is in the -1 column. That's the 7A column, but it has a -1 charge to it. So we're going to write chlorine and 1 negative. So now we have our 2 elements and their charges. But if you notice, calcium has a 2 positive charge and chlorine only has a 1 negative charge. So what do we need to do to make those charges equal 0? Well, we're going to have to take this -1 and turn it into a 2 negative. And that means we're going to add a 2 to the chlorine. So we're going to have 2 chlorine atoms. So if we end up having calcium, 1 calcium, and that's a +2 charge, and then we have 2 chlorine atoms, and each of those chlorine atoms has a -1 charge, we're going to end up with 2 chlorine atoms with a total of a -2 charge. So now we have calcium with a +2 and chloride or chlorine, and when you make that 2 atoms of chlorine, we get a -2 charge. So the +2 of the calcium and the -2 of the chlorine will equal 0. So we know that the answer to calcium chloride is going to be CaCl2. And that's going to be the ionic compound for calcium chloride. So let's try another one of these. So what if we want, and I'm just making this stuff up as we go along, but what if we want sodium nitride? So we have sodium is over here in column 1A. So sodium, and that would give us a 1 positive charge. And then, what did I say? Sodium nitride. So here's nitrogen over in the nonmetal section. So nitrogen is just the letter N, and it has a 3 negative charge to it. So this would be sodium, and this would be nitrogen. But since we're doing an ionic compound, we're going to cross out this ogen at the end, and we're going to add ide. So that makes sodium nitride. And so we have sodium with only 1 positive charge and a nitrogen or nitride with a 3 negative charge. Well, how are we going to get that 1 positive and 3 negative to equal 0? So we're going to have to take this 1 positive times 3, so we end up with a 3 positive. So that means we're going to have 3 of these sodiums. So we're going to write that down at the bottom in a subscript. 3 sodiums to equal plus 3 positive charges in order to neutralize the nitrogen's 3 negative out to 0. So what it's going to look like is sodium, 3 of them, and a nitrogen, and just 1 nitrogen, so we don't have to write 1 down there. You just leave that blank, and that's implied 1. So sodium nitride is going to be Na3N. So let's try one more. Let's say we're going to take calcium from the metals group and oxygen from the nonmetals group. So we're going to have calcium and oxygen in an ionic compound. Now, of course, the first thing you do is you write down calcium, the metal, first, and then the nonmetal oxygen. Then the next thing you do is you cross out the end of the nonmetal, in this case oxygen, and you add the suffix "ide" to it. So you end up with calcium oxide. Now, how are we going to write this as a formula? We got calcium, and if you look at calcium down here in the periodic table, that is in the +2 column. So calcium is going to have a +2 charge. And then we're going to look at the oxygen, which is in the -2 column over here in the nonmetals. So oxygen is going to have a -2 charge. Now, since this already has a +2 and this has a -2, +2 and -2 is 0, so they're already neutral. So all you have to do for calcium oxide is write calcium and then oxygen like that, calcium oxide. Now let's just do one more of these just to make sure that the math doesn't get confusing to you. So let's do, and again, I'm just making this stuff up as I go along, picking something from the metals and something from the non-metals. So let's do magnesium phosphide. So here's magnesium in the periodic table. Magnesium is down here as the metal. Magnesium, and that's in the column that has a +2 charge. And then we want to do magnesium and phosphorus. We want to put those together. So phosphorus is in the column that has a -3 charge. And don't forget, when we're putting these together, you take the metal name first, magnesium, and you leave it alone, but then you take the non-metal name, phosphorus, and you cross off the last part of the word there, and you make an "ide" instead. So you end up with magnesium phosphide. So far for magnesium phosphide, we have magnesium, which is +2, and phosphorus, which is -3. So since these two need to end up to be a 0 charge, a neutral charge, what you can just do is cross them, or some people say lasso them, because they'll say lasso the 2 and bring it down here, and lasso the 3 negative and bring it down here across the ways. So you end up putting a 3 down here with the magnesium, so make magnesium 3 atoms of magnesium, and then you take the phosphorus and you make that 2 atoms of phosphorus. So see, if you have, let me get another color, if you have 3 atoms of magnesium and each magnesium is a +2, you're going to get a +6 charge total. And if phosphorus, if there are 2 phosphoruses in magnesium phosphide, and each of those phosphoruses have a -3 charge to it, and you multiply those together, that's going to give you a -6 charge. So +6 and -6 cancel each other out and they make a neutral charge. So your answer would be Mg3 P2 would be magnesium phosphide. Okay, now so far we've gone through writing the formula and the names for ionic compounds, but we've just been using group A's, the A groups, in order to write these ionic compounds. Now we're going to get into the exceptions to what, or not the exceptions, but just to the extra rule that you're going to have when dealing with these transition metals. Transition metals. And this is all the way to the red staircase and all the way over to the left to column 3B right here. So these are all the transition metals. And the thing about it is that some of the transition metals have an extra rule when you are writing out the formulas for their ionic compounds. Now the transition metals that we're talking about is iron, and here's Fe for iron, copper, and here's Cu for copper, gold, and here's Au for gold, chromium, and here's Cr for chromium, cobalt, here's Co for cobalt, tin, and tin for some weird reason is abbreviated Sn, so that's tin, and then lead is Pb, and Pb is right underneath tin. And then we also have with that's a little tiny bit different that I'll explain on another page is mercury, Hg, and that's just a little bit tiny bit different than the other transition metals we're going to talk about. Now the reason why there's a couple of extra rules for these outlined transition metals is because these transition metals can have more than one charge to them. Like for instance, chromium is Cr, and Cr can actually have a 2+ charge or a 3+ charge, just depending on the context, depending on what formula it's in and how you're using it. So we're going to have this called chromium, and then in parentheses afterwards we're going to put the Roman numeral 2, and that means the chromium with a +2 charge. And we're going to have chromium with the Roman numeral 3 to stand for the chromium that has a +3 charge. So you're going to want to keep that in mind. So say for instance, if you have up here at the upper right hand of the screen, say we want to put together chromium and oxygen in an ionic compound. Well, oxygen is going to have a 2 negative charge to it. And chromium could have a 2 positive charge or a 3 positive charge. But since ionic compounds need to equal a 0 charge, we're going to know that we should pick the chromium with the 2 positive charge, because chromium with the 2 positive charge and the oxygen with the 2 negative charge is going to equal a 0 charge. So we're going to say chromium with the Roman numeral 2 after it, designating that it has a +2 charge, and oxide, because remember at the end of ionic compounds we take that nonmetal name, which is oxygen, and we change it to oxide. We put the "ide" at the end of it. So chromium 2 oxide. This can also be called chromous oxide. So that's just a fancy name for saying chromium with the Roman numeral 2 after it. If you were to have, so let's see, chromium 2 is going to be chromous. If you were using, however, a chromium 3, then that would be called chromic, and I'll get to what that's all about in a second. So here is a list except for mercury. Mercury I'm going to do on the next page just because it's a little bit different. But here are the transition metals that have different charges depending on what you're doing with them. They can have different charges, and I put them into little subcategories here. But but notice their actual names, their fancy names, all have the same pattern to them, and we'll get to that in a second. Let's start with copper up here at the top left. Copper can be either a 1 positive charge or a 2 positive charge. So that's going to determine if you say copper with a Roman numeral 1 after it or a copper with a Roman numeral 2 after it. The copper with a 1 charge, with the least amount of charges, is called cuprous, O-U-S, and the copper with more charge, the 2 plus charge, is called cupric, and it has that IC on it. Now gold can either be a 1 positive charge or a 3 positive charge. So it's different from copper. Copper can have either a 1 positive or a 2 positive charge on it. And by the way, all these transition metals all have different positive charges on them. So you don't have to worry about memorizing negative charges too. These are all positive charges. But so gold can have either a 1 positive or a 3 positive charge. So the 1 positive charge is obviously going to be called gold 1, gold with a 1 Roman numeral in parentheses after it. Or it can be called Aurus. And gold with a 3 positive charge is going to be called gold 3, or gold with a Roman numeral 3 after it, and that's called auric. Now let's look over here to the right. We have tin, which for some reason is abbreviated SN. Tin can have either a 2 positive charge or a 4 positive charge. So that means you're either going to call it tin 2 or tin Roman numeral 2 in parentheses after it, or the tin with the 4 positive charge is going to be called tin with the Roman numeral 4 after it. Now the one with the least amount of charge is the tin 2, so that's going to be called stannous. The one with the most positive charge is the tin 4, so that's going to be called stannic. Now here's lead. Lead is abbreviated PB, and lead can be either a 2 positive charge or a 4 positive charge. So of course the 2 positive charge is going to be called lead Roman numeral 2. The 4 positive charge is going to be called lead Roman numeral 4. And the lead with the 2 positive charge is the least amount of charge, so it's going to have us, O-U-S, at the end of its name. And the lead with the most positive charge is the lead 4, and that's going to have ic at the end of its name. So are you noticing a pattern here? The element with the least amount of charge ends in OUS. And then with the most amount of charge, it's going to be the element's name, but it's going to end in IC. So remember when we do ionic compounds, the non-metal, we're going to change that name to an ending in "ide," like oxygen becomes oxide. But when we're dealing with ionic compounds and the first name, the metal name of it, is one of these weird transition metals, then if we're using the least amount of charge for the transition metal, we're going to also change the end of that name to OUS. If we're dealing with the transition metal with its most amount of charge, we're going to change the ending of that name to an IC. Now here is the rest of them right here. There's iron, and iron can be either a 2 positive or a 3 positive charge. So that's going to say what Roman numeral comes after iron when we're talking about it. And of course with the least amount of charge, the 2 positive, it's going to be called ferrous. With the 3 positive, the most amount of charge, it's going to be called ferric. Now chromium is abbreviated CR, and it's going to have either a 2 or a 3 positive charge. So that's going to say whether you say chromium Roman numeral 2 or chromium Roman numeral 3. And the chromium numeral, or chromium with the positive 2 charge is the least amount of charge, so that's going to be Chrome-us. And then the chromium with the most amount of charge is going to be the chromium 3, so that's going to be chromic. Now finally, cobalt. Cobalt is abbreviated CO, and it can either have a 2 or 3 positive charge, and that's what tells what Roman numerals we're going to put after the name. And so the cobalt 2 positive charge is going to be called cobaltus, and the cobalt with 3 positive charge is going to be cobaltic. So say you want to take iron's right here, and you want to pair iron and oxygen in an ionic compound. Iron and oxygen. Well, we know that oxygen is going to have a 2- charge on it. And so iron, which iron should we use? Because whatever the charge is for iron, we want it to cancel out the charge for oxygen because we want it to have no charge when we add them together. So obviously we're going to use the iron with a 2+ charge to it, with the oxygen with a 2- charge, so that ends up adding up to be equal to be 0. So we're going to call this, since we use iron with the 2+ charge, which is called ferrous, we're going to call this ferrous oxide. Because remember, this is an ionic compound, so you want to take that last word, that oxygen, and you want to change the ending of that name to "ide." So, and then the ferrous, the us, means we're taking the iron with the least amount of charge to it, and that's the iron with the 2 positive charge to it, so that's going to be ferrous. So ferrous oxide would be iron and oxygen together in an ionic compound. Now mercury, I'm just doing on a different page because it's just slightly different than the other transition metals that have the multiple charges to them. Mercury is abbreviated Hg, so that's mercury. Now mercury can have 1 charge to it, or it can have 2 charges, 2 positive charges to it. But here's the difference between all the other ones, which is why I wanted to put this on a different page. But the mercury with a 1 charge to it never comes alone. It always comes in pairs. So it always comes in as a mercury 2, 2 mercuries. So if you have a mercury that has a 1 charge to it and another mercury with a 1 charge to it, you're going to end up with a 2 mercuries that has a 2 positive charge with it. So since each mercury only has a 1 positive charge to it, we're going to call that mercury 1, and that's 1 in Roman numerals after the mercury. And that's going to be called mercurous. Because remember, the least amount of charge, you're going to have the OUS at the end for these transition metals. Now also, we have a mercury that is just naturally by itself has a 2 charge to it. So we're going to call that mercury 2 with Roman numerals and parentheses after it. And that, of course, is going to be referred to as mercuric because that has more of a charge to it. That has 2 positives charged to each mercury, whereas the top one here has 1 positive charge for each mercury. It just comes in a set of 2. Okay, so there can be a mercury two mercuries, and that's going to have a +2 charge. That's going to be called mercury number 1, or mercurous. And then we're going to have a regular old mercury, and that's going to also be a +2 charge. So that's going to be called mercury number 2 in Roman numerals, or if you want to get fancy, you can call it mercuric. So just be sure when you're using transition metals, the transition metals I just mentioned, to make ionic compounds, you have to choose which transition metal is going to be right for the job. So say if the transition metal is going to go with oxygen, oxygen naturally has a 2 negative charge to it. So you're going to pick whatever transition metal is going to have a +2 charge to it so they can cancel each other out. Equals no charge.